So if you guys look at 17, got two that are in, and notice how they took the outside. Because if it's inside, what's that mean? If I'm adding and subtracting inside a set of parentheses, left or right. And if it's outside, it's up or down. So that's what you just had to figure out. And you start with the New York State gas prices, which according to the key is your solid dot. So this one right here. And you want to know how you're getting to the national average, which is the starred one. So you guys tell me right now, from the New York State one to the national one, you tell me what direction this bad boy's going. 2, what direction is it going? It's going down. So you had to figure out which one of these meant going down. And that choice is pretty sure. Yeah, you're darn right it's 4. You don't have to be pretty sure it's 4. Okay? So that's really all that one was asking. What's 1? Left. That is left. 3 is right. 2 is up. All right. All good? Okay, how about this Venn diagram one? What's the probability of students a sophomore? There it is right there. There's the huge one about given they're already enrolled in Algebra 2. So you should not be looking at this entire Venn diagram. You're only looking at what? Algebra 2. They're already in Algebra 2. So this is not out of whatever these numbers are added up. It's out of only what now? It's not out of 210 either. 210 plus the 85 that take both. Okay, because 210 take Algebra 2 only. There's 85 that are Algebra 2 and sophomores. All right, so 210 plus that 85, and then out of that right now, I'm going to ask somebody how many are sophomores out of that right now. Out of that circle only, how many are sophomores? 11. How many are sophomores? 85. And I think that adds the 295. Okay. Given they're already in. So is everyone all right why I'm only looking at that part of the Venn diagram? All right, how'd 22 go, huh? Anybody know what they're asking? I get it. They go from the bottom to the top. I can read that. What am I asking here? Fancy way of saying find the what here? Yeah, half the period. Because the full period would be what? Bottom to bottom, right? But we're only looking for bottom to top, so I need half the period. All right, open it up to you guys. What's the period formula? Oh, yep, 1. Here we go. Period equals? Yep. Not on your formula sheet? Oh, boy, we got a lot of values up here. Which one is the B value up here? Which one is the B value? Let's go. Here we go. 2. Which one's the B value? Nice job. Pi over 45 is your B value. How do I solve that? Yep, keep, change, flip, or whatever you remember. 2 pi times 45 over pi. Cancel what you can and let me know what the period is. 1 again. What's the period? 90. And again, why this is so darn difficult, even to get 26 points, look what a choice is. 90. Of course, pick me. All right, you did this beautiful calculation. 90. Pick me, please. Pick me. But we said it's half the period, right? Because I'm only going to go from bottom to top. This would be bottom to bottom here. 45. What's the 150? I'm covering all my bases here. What's the 150? Amplitude. 150 is the amplitude. What's the 160? That is the C value, known as what? It's out. We just talked about it. It's outside. What is it? It's a shift. Shift up 160. What's the 67.5? Phase shift. Yep. Where's it going? Left 67.5. Yep. All right. There it is. All right. There's other questions I could ask, but. And your part twos. This is 2 points here. Hard to get a partial credit. I don't know. Can you factor that? The 13 I have of you in here. Can you factor that? How many terms are there? GCF? Nope. Now, if you told me an even number of terms, we might be able to group, but can't group here. Can't group with an odd number.
What if it's still grouped because I just took apart the 4x squared and did negative 6x squared plus 2x squared, and then group from there.
How'd you group it though? Like, how'd you know what to turn it into?
Because I just took it apart.
What do you mean took apart? Like, how'd you know, like, did you do 2x squared and 2x squared? Did you do 1x squared and 3x squared?
Well, because I just figured out what would equal negative 4 and still give me 4 terms.
But yeah, how'd you know if it wasn't -2 versus -3 -1? Like, how'd you know what combination to pick?
Find out what equal 12 also.
Okay, well, let's just see if we ended up at the same spot at the end. All right. Two numbers that multiply to what? Yeah, multiply to 12 and add 2. Okay, here we go. I'm going to ask somebody right now. Multiply to -12, but add to 4. 7.
Oh, I just got here. What's the thing?
10. -6, +2. All good? And then these two here have to multiply to what? X to the 4th. Usually you guys would just put x and x, right? To get it to be x squared, but nope, x to the 4th. So what do I have to put on here now? Good? Okay. Go any further? Go any further? No, 6 is not a perfect square. And I'm not even dealing with 2 because it's +2. All right, all good? And then, hey, look what happened. Look at 28, huh? Basically going, here is a free 2 points, everybody. Here is a free 2 points. Too bad some of you won't get a free 2 points because you don't know how to use the darn calculator yet. All right, come on. Where am I going? Normal CDF. And remember, you got to show me this for work. Got to show me this for work. Lower bound, what are you typing in? 200. By the way, I'll talk about it at the end. I don't want to break this up. Upper bound, 245. Next value is the mean you plug in. 225, followed by the standard deviation. 18. There we go. What your calculator gives you is not my final answer, though. There, I'm asking, reread the problem. I'm not asking for what's the probability or the percent. Everyone got your number? So about a 78% chance that you scored between the 200 and 245, but I want to know the number of students. What am I doing with that now? What am I going to do with that to find the number of students? 10 again. Yep, I take that number, multiply it by the 1,200 students there are. And then you guys can do that about how many students? 1, about how many students? I don't know how else.
Yes,
9 what?
36.
1,200 times that?
That's what I got. Is it because we rounded it? Because I just rounded it to 47.
936. Yeah, okay, yep. All right. Thank you for doing that then. Thank you for doing that. Yes. Okay, right? Is that your final answer? No. So we don't round anything until the very end. Okay? Do not round anything to the end. Thank you for making that mistake. All right? Do not round anything until the end. Keep the full calculator display all the way through. We all good here with 28? Which, by the way, also brings me to, did anybody snag one of my calculators yesterday by
I
accident?
did. I did.
And where is it now?
It's on my bed.
Okay, can we bring that in? Because if it doesn't get brought in, then I'm not putting any calculators out.
Okay.
Okay? We all good here?
Ray, I swear to you. What?
All good? That's just the way it is. One goes missing, they all go missing for me. All right, here we go. Got to finish up the stats unit. Guys, we've been denied 2 days here. Okay, the snow day after Thanksgiving and then Tuesday with going home early, which means we've been denied 2 extra days to review for the Regents. So now instead of 10, we have 8. Okay, which means now I'm in a real crunch as far as getting this unit done. So you have 8, right? So what I've decided to do is part of the day's notes I may not do. I may just skip over because I know it has nothing to do with the unit test and nothing to do with what you need for the Regents exam. Okay, just because it saves a lot of time that we can still review. Because I have a feeling that if I try to do every single thing, we won't get 8, we'll get 7 or 6. All right, so for instance, like today, I was going to start class off with a mystery bag and everyone would pick chips and let's have an educated guess on how many red chips are in the mystery bag. Okay, that was supplemental to what I really needed to tell you. Okay, so I'm skipping over that part right now. Okay, I'm skipping over that part and I'm going right to page 17 in your packet. Okay, again, believe in me that it's nothing that would have been needed anyway for the Regents or the unit test. Have you guys ever seen, you don't have this on yours, so just look up here. You guys ever seen something like this on the news or on Twitter or any social media platform? Specifically, have you ever seen that?
Yes.
Exactly. But you've seen it. You're going to learn what it is today. Okay? That you always see this plus or minus whatever percent it is. I've always seen it like election years, like when they're voting for presidents and stuff, and I always see, oh, plus or minus, whatever that is. Here's what that means. All right? This is out of an entire population. You remember the first day we talked about population, that's everybody? And it's basically virtually impossible to get to everybody. But they're saying 41% of everybody said yes. That's impossible to get 41% exactly because they didn't poll everybody. What did they poll? No, what did they didn't poll everybody. What do we call the smaller? They polled the sample size, right? Okay, so this is what it's saying is out of the sample size we polled, 41% said yes. But, ready? Here's what this means. We may be off by 3.8% in either direction. So this doesn't really mean 41% said yes. What this means is, got your calculators ready? 41 plus 3.8. 44.8. And then 41 minus 3.8. 37.2. What this is really saying is, we don't think 41% said yes, but we're pretty confident 37.2, between 37.2 and 44.8% said yes. That's what that means. Because why again? Can I get to everybody? No. So this 41% represents a sample of the entire population. But because they gave me this, I'm pretty confident the population, 37.2% to 44.8% said yes in the entire population. That's what I'm pretty confident in. All right, so that's what that means. This could be off by 3.8% in either direction. Good? All right, we're going to give a name to this now today too. That plus or minus 3.8, it's called the margin of error. Okay, it's called margin of error. All right, we could be off from the mean. Our average could be off from this or this. And there's a formula for it, and this is the formula you guys are going to use to find margin of error, not located on the formula sheet. Which, by the way, when we start really hardcore reviewing for the Regents, I will give you a 2 to 3 page packet of formulas not on the formula sheet you're responsible for all in one. Okay? So you don't have to write it down yourself, because who knows where it would go. All right, so formulas. First one, is everyone all right if I just abbreviate margin of error, MOE? The MO. Here's how you find that number. I'm going to take plus or minus 2 and multiply it by the standard deviation. Okay? I'm going to multiply it by the standard deviation. So that's how they got this right here. Whatever the standard deviation was in their calculator, they multiplied it by plus and minus 2. Okay, so I want you to do it with me right here for number 3. Okay, try it out here with me. I did a little dot plot. You guys are going to make one up on your own in a second. The mean came out to be, for this little sample here, it came out to be 0.502, excuse me, and the standard deviation came out to be 0.046. What's my margin of error? Okay, ready? Here we go. So for this one, plus or minus 2 times, what did I give you as the standard deviation? You even need to use your calculator for it. 0.046, come on. So we're going to say our margin of error, we're going to keep that plus or minus there and just really multiply by 2. That margin of error ends up being plus or minus 0.092. So here's what we're saying. Based on that little sample you took, the mean for the entire population might be off by 0.092 in either direction. Okay? Is it exactly 0.502? Probably not, but we're pretty confident it's 0.092 off in either direction. Good. All good. All right, now what I want to find is what's called the confidence interval, which is, all right then, if that's not the mean of the entire population, at least give me a little interval on which you're confident it's between. All right, and the way we find that interval is we take whatever the mean of the sample is and add and subtract your margin of error. There we go. Okay, that'll give me an interval we're pretty confident the population mean is between. Yes? Confidence interval. Confidence interval. Okay, so what was our mean in this one? 0.502. We're going to add the margin of error and we're going to subtract the margin of error to get our confidence interval. So you can go right ahead, take 0.502, subtract 0.092, and then add it. And then we'll get an interval which we are pretty sure the mean, population mean is going to be between. We can never get it exactly, but we can get a little interval in there. And what's our confidence what's our confidence interval here? 0.4124 to 0.5. Nah, bruh. Okay, I'm looking at the wrong one.
Hold on here.
Yeah, okay, I'm done. All right, I'm sorry. I'm looking at the next one. Okay, this is my bad, brother. Yeah, my bad. I got it. 0.41 to 0.594. How about that? Better? There we go. Okay. So again, what are we saying now? I don't think the mean for the whole population is 0.502, but I'm pretty confident it's between these two here. Okay? Last thing I got to talk about, how confident? How confident are we? 95% confident.
Pretty solid.
It is. And whoa.
Easy there. Oh,
90, 95?
that's 2.
95?
That's 2 on the
I believe we've heard that number before. That's within what? How many standard deviations?
2.
Hello. That's why we multiply by 2. All right.
So if you wanted to be
Okay.
less confident, you multiply
So that's what we're finding. The confidence interval is from -2 to 2. 95% of it falls under there. All right. That's where all that ties in. Any questions from you guys? Going. I have a question.
Ask away.
Sure. I put more samples on here. I put more samples. Well, do you think my margin of error is going to increase or decrease? I get more samples. So I put more dots here, more dots, more dots. I go out and survey more people. What do you think happens to my margin of error? Increase or decrease my margin of error? It's going to decrease. Yes, it's going to decrease. And last question. How do you think this dot plot's going to look more like? Spencer? It's going to more resemble our curve the more we get. It's pretty good right now, right? All right, the more we get, the more it's going to represent the bell curve. Nice job, Spencer. Questions there? You take stats, is that why?
I did, yeah.
Okay. Good? All right. So one more. Speaking of bell curve, how about the looks of that bad boy, huh? How about the look of that bad boy? That looks familiar, huh?
That looks good. That looks great.
Yep. So I guess this represents the proportion of people who spend at least 15 hours of studying. I don't know if it's weekly or monthly or yearly. I don't know. All right. So just so you know what this means, right here, that's 41% of the people surveyed spent at least 15 hours studying. Here, there's 49%. Here's 50%. Okay? All right, so let's find our margin of error first, because they're saying the mean is 0.4504. So plus or minus 2 times, what's my standard deviation? 0.19. That's great when they give that to us, huh?
What if they didn't, though?
If they didn't, I would never do this to you. If they did it, we'd be going to L1 on your calculator and putting in 0.4, 0.41, 0.41, 0.41 and calculating it that way. I'm not going to do that to you. Everybody calm down. I'm never going to do that to you.
Chill out, Lauren.
No.
Stop yelling. Chill
Okay.
out.
Margin of error, what do you have for me? Point, plus or minus. Don't forget your plus or minus, 0.038. So that we're saying that mean could be off by 0.038 in either direction. So once I know that, what's your confidence interval now? We're 95% confident that the population mean will be between what and what? So I take 0.4504, add and subtract 0.038. Here's what I was talking about earlier. What do you have, 0.4? I know it seems like a big range of scores, but we at least can be 95% confident that the population mean will be somewhere in between there. All right, ready? Ready to do our own little dot plot here now and do this all ourselves. You don't have to find margin of error confidence interval, though. I just want to make a dot plot and answer questions of it. All right. Before we start putting dots everywhere, I want to make sure you guys know what's happening in this one. We're going to take 28 juniors. So I'm going to, let's just assume you're all juniors now. All right, going back a year. And I want to survey all the juniors and seniors in the high school with part-time jobs. So here's basically what has happened right now. I tell Pat, get out there in the hallway, grab 30 juniors and seniors and see how many have part-time jobs. He comes back. Out of the 30 I surveyed, 70% have part-time jobs. That's why there's the 0.7 here. Good? Everyone good? I tell Spencer, get out there. Survey 30 kids. Come on back. He says, well, out of the 30, 80%. So everyone is surveying 30 people. Everyone see that? So we're talking about a ton of kids, right? Because each of these proportions represents 30 kids. Okay? Everybody good? Yes? Okay. So now what I want to do is actually make our own dot plot of all these. So the first thing we need is, well, what's the least, what's the greatest? What's the least proportion up here? Anything less than 0.4, anybody see? Okay, so 0.4 has got to go on one end and on the other. What's the highest here? I got 0.4 and anybody see the highest? I think there's higher than 0.77, 0.8. So we got to go from 0.4 to 0.8. Do I preferably want to go by 0.01? Probably not. So if we start at 0.4, what are you guys suggesting?
Well, my point. Still 0.03. What? Let's go crazy. What?
Why aren't we writing 0.47?
There's a 0.4. There is a 0.4.
Right here.
Oh, found it.
Okay. I don't want to do like 0.41, 0.42 because some of them aren't going to have any dots. All right, some of them aren't going to have any dots. So we got a different, what do you want to go by? Point, okay, 0.5. That's what I ended up going by.
Nice.
So 0.45. What are we going up to? 0.8. Okay. And now we got to be careful. Put your dot. So first one, what do we got? 0.7 dot. Did it. 0.8 dot. And I think you can take it from here. Now, when you got 0.57, estimate. Doesn't have to be exact. 0.63. Okay, I'm going to stop talking to myself so you guys can do this on your own. Yep.
they go out and just sample random juniors, like what if they just sample the same kids over and over?
Obviously they do.
Depends on your technique, I guess.
Yeah, I was thinking.
Depends
like,
on your
would-
technique.
Would this like be actual data that people use, or like? 'Cause that
Could be.
Doesn't seem legit.
Depends how big the high school is too. You know, you got a huge high school with a ton of seniors and juniors. It's probably not a great idea to try to get to all of them, so we do a sample, right?
Yeah.
Okay. Everyone good with their dot plots? All right. Just based on the dot plot, do you think that all proportions of juniors and seniors could be 0.7? Based on what we did, do you think it could be 0.7? Could be, not is exactly, just could be. Could it be 0.7? Yeah. Why? Because where are a majority of my points around? 0.7. Yeah. If you told me, how about, do you think it's 0.3? I'd say absolutely not. There's not even anything close to it. Do you think it's 0.4? Probably not. Just because one kid was there doesn't mean it's going to be a majority of them. All right. So for at least 0.7, yes. Because a majority of the proportions are around it. Not dots, a majority of proportions. Are around 0.7. What do you think about 0.5? Do you think it could be 0.5? No, probably not. You're right. Why not? There you go. I like that wording. Very few proportions around 0.5. And then I got one more for you. This is 30. This is 30. What happens if I would increase the sample size to 60? This is, all of you did 30. What if I said go out again and get another 30? How do you think the dot plot would look now? That's what it's asking. How do you think this?
More like a bell curve.
It would look more like a bell curve, which means, ready? These right here would be more where? Towards the middle. They get scrunched more towards the middle. Yes. It would resemble more of a bell curve. Correct. All right. And what would happen to your margin? I'm not going to write it, but what would happen to your margin of error? It would go down. Nice, kids. Tonight, please, or right now, actually, you can start it. Do not do 2 and 3 on the assignment on the next 2 pages. Yes, so I'm asking for number 1, 4, and 5 to get done. Woo! Laying it on thick, and 6, excuse me. Okay, 1, 3, 1, 4, 5, 6. That's it. Okay, and then tomorrow, hopefully you'll be here because we're going swimming with dolphins.